In Module 2, we're going to talk about the Nexus 9000 hardware platform. We're going to talk about the roles that switches have in the ACI fabric. We're going to talk about spines and leafs. And then we're going to talk about the ASICs, the chips that power, the switch-on chips that power the Nexus 9000 family. So the Nexus 9000 platform from Cisco can operate in one of two modes. We have the ACI application-centric infrastructure mode, which is what this class is based on, and also a more traditional NXOS mode. So it runs individual configurations on each device, whereas ACI configuration is centralized on the APIC cluster, and then the APIC cluster controls the nodes themselves. For the 9000 at a glance, we have three families of Nexus 9000s. We have the 9500 series, which are a modular chassis-based platform. We have the Nexus 9300s, which are fixed platform. They're meant to be top of rack and end of row. Although there are two models that can take upgradable modules, so somewhat modular. And then we have the 9200 series, which are all fixed platform switches. The 9500 series and the 9300 series can operate in NXOS mode or ACI mode, and the 9200 series currently can only operate in NXOS mode. So as such, we're not going to talk much more about the 9200s. So we're going to be concentrating on the 9500s and the 9300s. Now, the thing to understand about Cisco ACI is that the switches have different roles. Because of the way that ACI is architected, some of the devices need to have certain functionality and others need to have different functionality. So that means typically a difference in the chips. So there are two primary roles in Cisco ACI. We have the spines and then we have the leaves. We also have the APIC controller cluster. So typically that's a cluster of 3 C-series based appliances. Although in lab situations you can have just one, and I think currently in the 2.0 release of ACI we can expand out to 5 nodes. We'll talk about that later when we get to the APIC section, which is next. But for now we're going to talk about just in generalities. In the spine layer, the Nexus 9500s are the only ones. The Nexus 9500s only exist as spines in ACI. So while in NXOS mode you can run them in a variety of roles, for ACI, the 9500s are spines. There's also the 9336, which is a 9300 that can operate as a spine as well. We call that the baby spine. On the leafs, they are only 9300s at this point. Connectivity between the spines and the leafs is 40 gigabit per second or higher. So the first round of hardware was 40 gig from the leafs to the spines, and the new round of hardware can be up to 100 gigs from the leafs to the spines. So let's talk about the spine switches. We have two choices. We have the 9500 series, which is the 9504, 9508, and the 9516. And there are two line cards that are supported as spine. One is a 36-port 40 gig line card, and the other one is a 32-port 100 gig line card. We also have the ability to use a 9396 PQ as a 36-port 40 gig fixed switch as a spine. They typically used in lab environments, or you can do a small to medium-sized ACI installation. For the modular product family, we have the 9504, the 9508, and the 9516. Now, if you're familiar with the 7000 series or the 7700 series of Nexus switches, one thing you'll note is that, for example, a 7710 has 8 payload slots. 2 of those 10 are reserved for the supervisor modules. In ACI, the numbering convention is a little bit different. We do have the supervisor modules, but they don't count in the number of in the model number. So the 9504 means we have 4 payload slots. The 9508 means, yep, you guessed it, 1, 2, 3, 4, 5, 6, 7, and 8. 9516 is, as you also might guess, is 16 payload slots. They run most of the components between the 9504, 9508, and 9516 are identical between them. So, for example, the supervisor modules are interchangeable. The controller cards are interchangeable, and the power supplies are interchangeable. The things that are not interchangeable between the different models are the fan trays and the fabric modules. The The supervisor event engines run the control plane for Cisco ACI. So we do have a separation between the APIC controller and what we consider the control plane and the data plane. Typically 2 are used. You can get away with just 1, but in ACI almost everything is spec'd out in 2s just for redundancy. Another change from the 7700s is we have the controller cards here, which are a separate function than we typically have in the 7700s. The 7700s, we have both the higher level functions and the lower level functions. So what do I mean by lower level functions? Lower level functions are things like maintaining fan speed, monitoring temperature. If the temperature increases, fan speed decreases, etc. So those things are controlled by the supervisor modules and the Nexus 7000 series. In the Nexus 9500 series, those functions are split between the supervisor engine and the controller cards. So the controller cards are managing what's going on in terms of the autonomic functions, or the higher level brain functions. The control plane is on the supervisor modules. The power supplies, for the 9504 and the 9508, 2 power supplies are required to power an entire chassis fully loaded. 3 power supplies will give you N+1 redundancy. 4 power supplies will give you AB grid redundancy. So if you're running 2 power grids, you can use 4 power supplies. With the 9516, it's just double that. So we need 4 to power the entire chassis, 6 to give us N+1 redundancy, and then or 5 can give us N+1 redundancy, and then 8 if we want to do grid redundancy. So the spine line cards, we have a 40 gig spine line card and a 40 and 100 gig line spine card. So the 9736PQ over here, right there. That was when ACI was first released, that was the ACI spine card that was supported. You can still get it today. It's 36 ports of 40 gig Ethernet interfaces. It's QSFP Plus. It's got 42 megabytes of buffer, line rate for all packet sizes, and requires 6 fabric modules for the 9500s. So whether or not you have the 9504, 08, or 16, you still require 6 fabric modules to get full bandwidth out of this. The new generation, based on 25 gig lanes, so the 40 gig card is based on 10 gig lanes, the 100 gig line card is based on 25 gig lanes. So it's 32 ports of 100 gigabit Ethernet. It runs the QSFP 2.8 interface. Now this is a form factor that physically, at least dimensionally, is identical to the QSFP Plus interface. So the sizes of the slots are identical. And if you have leaves that are 40 gig only, you can still plug them into these interfaces, and rather than run at 100 gig, you can plug in a QSFP Plus and you run them at 40 gig. It has 160 megabytes of buffer, can operate at 40 gigabit if we need it to, line rate for all packet sizes, and requires 4 of the 2nd generation fabric modules in order to get full bandwidth. Another interesting aspect about the new 400 and 100 gig line card is that this line card can run in both NXOS and ACI mode, providing some investment protection. So if you invest in an ACI fabric and you decide you want to do a different type of fabric down the road, a non-ACI fabric, you can turn it into just a regular NXOS switch and running traditional layer 2, layer 3. The 40 gigabit ACI line card, however, can only run in ACI mode, so you cannot run it in NXOS mode. So it's only you can only use it in ACI. The 9500 series do not have a mid plane. What they do is instead they have line cards and they have fabric modules. The fabric modules provide the connectivity from one line card to another line card. And when we get into the ASIC section, we'll talk a little bit more about how that connectivity works. So it makes airflow very easy. We don't have to do side-to-side airflow. We can do front-to-back. It also, these fabric modules are based on either 10 gig lanes or 25 gig lanes, or a 40 gig fabric modules or 100 gig capable fabric modules. When ACI first came out, there was the 9504, 9508, and the 9516 FM. So these are the fabric modules for the first generation of hardware. It's based on the Broadcom Trident 2, sometimes referred to in the Cisco world as the NFE, Network Forwarding Engine. and it's a 40 gig based fabric module. It can run in NXOS and ACI mode, so it supports line cards for both. So whether or not you're running the ACI spine card in 40 gig or you're running the 10 and 40 gig cards in NXOS mode, doing layer 2, layer 3, doesn't matter. They both run on the same fabric module. In the move to 25 gig Ethernet, we have two different line card options. We have the 9504, 9508, 9516, although I'm not sure the 16 one is out yet, at least in August of 2016 when this course was updated. Fabric module -S. This is NXOS only, so we're not going to talk much more about it. It is based on the Broadcom Tomahawk chip, so that's often referred to as the NFE2 network forward engine number 2. It's a 100 gigabit based fabric module, and again, only runs in NXOS mode. The 9504, 08, and 16, again, I don't think the 16 has been released yet, but the 9504, 08, 16 FM-E fabric module. This can run in ACI or NXOS mode. It's based on a Cisco ALE2 ASIC, so it's not based on anything from Broadcom. And it is also a 100 gigabit based fabric module. So for this course, we're only going to be talking really about the first generation and second generation ACI capable fabric modules. The first generation fabric module, if you put 6, so each of the 9504, 9508, and 9516, they each have 6 slots for fabric modules. So we can put 6 times fabric modules in those. That should be an F there. Fabric module. So we can take 6 of them, and then if you put all 6, we provide a maximum amount of bandwidth of 1.92 terabits per second per slot. The second generation ACI capable fabric modules would give us 3.2 terabits per second per slot. So that's, and we only need 4 of those to do that. So that would be 4. We don't have to populate all 6. We'll just populate 4 with the second gen ACI capable fabric modules. And that's going to get us full line rate for 32 port 100 gig line cards. We also have the ACI 9396 PQ spine, or often referred to affectionately as the baby spine. This switch is a 36 port 40 gig switch. It can only be used as an ACI spine. It cannot be used in NXOS mode, and it can't be used for any other purpose other than an ACI spine. It's 36 ports of 40 gig Ethernet. Typical power consumption is 400 watts. It can go up to a 600, I think, is the maximum. And it's typically used in lab environments and small to medium ACI deployments. We can certainly, with 2 of these, we can certainly support a large number of leaves with all these 36 gig, these 40 gig ports. They can operate. They cannot be broken out into 10 gig ports because all connectivity between the leafs and the spines are 40 gig or better. And again, this can only be used as a spine. But this 9336, if you have a pair of them or up to 6 of them, are supported as spines. Right, currently with that 2.0 release, I believe 6 spines are the maximum. Whether or not you're doing the 9300s or the 9500s. So it can support, even the 9336 can still support a pretty good number of leaves. It also has reversible airflow, so it can do front to back or back to front. So now let's talk about the ACI leaf switches. So the leaf switches are the 9300 series. The 9300s can only be leafs except for the 9336 PQ, which we just talked about, which is a spine. They can also operate in NXOS mode. They are leaf to spine connectivity is provided at 40 gig to 100 gig. The leaf to host connectivity, so these ports here, typically the yellow ports, when operating in ACI mode, those ports are what plug into the ACI fabric, and the rest of the ports are host-facing ports. These are the ones that go to the host. Sometimes they're not yellow. Those would be the uplink-facing ports going up to the fabric, and the rest of these ports would be facing down towards the host. We can provide anything from 100 megabits per second interfaces to the host to 1, 10, and now 25 or even 40 gigabit per second connectivity to the hosts. Or it doesn't have to be a host. It can be like a router to your external layer 2, layer 3 connectivity. It can be into a firewall or a load balancer or some other appliance, or to your hosts. Basically anything that's not plugging into the spines. And the only thing that plugs into the spines are the leaves. You don't plug routers into the spines. You don't plug layer 4 devices. You don't plug firewalls or load balancers into the spine. Everything plugs into the leaves. And the 9300s can operate in either NXOS or ACI mode, with the exception, again, of the 9336 baby spine. So here are the 9300 10 and 40 gigabit leaf switches. First off, we have here the 9332PQ switch. So that has 28 ports. So this is 28, it's kind of hard to read there, apologize. 28 ports of 40 gigabit per second connectivity down to your endpoints. Again, routers, it could be an external router, it could be a firewall, load balancer, etc. And then we have 6 of those going up into the fabric. So we have 32 ports total. I'm sorry, that's 26 ports. My mistake. I can't do math here. So this is 32 ports total. 6 of them are dedicated to go up to the fabric, and 26 of them, because 26 plus 6 is 32, 26 of them go down to the host. We also have the 9372 PXE. So that's, again, 6 ports going up to our ACI spine, and we have 72 ports here. That will go down to the host that operate in either 10 or 1 gigabit with SFP plus interfaces. The 9372 TXE is the same switch, except these are 10 gig base T interfaces. Same thing for the 93120 TX. Those are 10 gig base T. So if you have copper going down to your into your nodes, then you would do this, and then we have 6 ports going up. Now, something to keep in mind. When we get to the APIC section, we'll cover this again. But I just wanted to mention real quick here, the APIC cluster. So those are 3 C-series based APIC appliances in a cluster together. So we need 3 of them. Unless we're doing a lab, we can do 1. But they use the Cisco VIC card, the UCS VIC card, and they come in fiber only. So, and they need to be plugged directly into a pair of leaves. So if you have any of these, which are the 10 gig base T, which are the copper-based interfaces, make sure that you have a pair of leaves that have the fiber-based interfaces. Otherwise, you're going to have a problem plugging in your APIC controller. 9396, this is the modular. This is a gem module we can upgrade and replace. This has 12 uplinks. There's also a 6 uplink model. And depending on which one of these you plug it into, the 9396 or the 93128, both of them use the same gem module. You can move one gem module from one to the other, so they both support the same gem module. If you plug it into the 93128, only 8 of these are actually active. The 9396, all 12 of them are active. So these are the top of rack end of row switches. The leaf modules themselves, there's a 6-port and a 12-port model. The 6-port is the newer one, and there's 2 versions of the 6-port. There's the M6PQ and the M6PQ-E. The difference, the E means that we can support IP-based endpoint groups. That'll become a little bit more clear when we get into some of the ACI artifacts and we talk about endpoint groups and what they represent. Traditionally in ACI, they're mostly VLANs. They can be other things too, but an endpoint group is typically segmented via VLAN. The -E means we can not just do it by VLAN, we can also do it by just an IP address. So we'll talk about a little bit later why we would want to do that. The 9372 PX and TX-E. There's actually 2 versions of the 9372 PX and TX line. One of them is with the E, and one of them is without the E. The only difference between those is the ability to do IP-based endpoint groups. So it was just a respin of the ASIC to add that new little bit of functionality. You can mix and match them. If you want to do IP-based endpoint groups, you have to plug it into a -E capable leaf. But you don't have to build an entire fabric based on -E capable leaves. You can mix and match them. And these are the newest 9300 switches. These are based on the 25 gig Ethernet technology. So 25 gig Ethernet lanes. So we have the 93180YC-EX. They are capable of IP-based endpoint groups as well. We have 6 ports of either 40 gig or 100 gig going up to the ACI spine. And then we have 48, 1, 10, or 25 gigabit interfaces going down to a host. So this is supporting, or not host again, it could be a firewall, it could be a load balancer, it could be an external router, but it supports 1, 10, and 25 gigabit Ethernet interfaces with 6 100 gig interfaces going up to our spines. Now, if you get the switch and your spines are 40 gig capable, then these 100 gig interfaces can operate at 40 gig. It's got 40 megabytes of buffer and is based on the Cisco ACI ASIC. We also have the 93108TC-EX. So this provides us, again, with 600 gig interfaces going northbound up to our spines. 48 copper-based 10 gig base T ports, which can operate at 100 megabits per second or 1 or 10 gigabit. So there's currently not a 25 gig over copper, at least not yet. And even if there were, I don't know that this switch could be upgraded to that. That's a good question. I'll have to find that out. So we've got 40 megabytes of buffer, and again, it's based on the new Cisco ACI ASIC. NXOS and ACI mode are supported on these, of course. Also, the EX designates that it supports something called Cisco Tetration Analytics. So this is really high-end telemetry. So if you want to check that out, then just go to cisco.com and look up the new Tetration product. They also support FCOE, so this is new to ACI. The ports that you plug in can be FCOE NPV ports. So it's not a fiber channel forwarder, but we can do NPV. Switch installation, best practices, verify airflow. We can do front to back or back to front. The fans are color coded. If they're red, that means we're getting hot air out, so that's front to back airflow. We're taking air from the front and then blowing it out the back. Blue means it's the opposite. So blue means cold air is going in to the back, and then hot air is going out to the front. So whatever, make sure you order the right fan module for that. Where to connect the spines, we talked about this a little bit earlier. These ports here, typically designated in yellow, but not always, go up to our spines. So spines can only be connected to leaves via the 40 gigabit module. So these ports here, which are 10 gig, or on the newer ones can be 25 gig, they're not capable of being plugged into the spines. Spine connectivity is 40 gig or better. FEXs are also supported in ACI. They're supported in NXOS mode as well on the 9000s, and they're also supported in ACI mode. There's a number of different models that are supported. I think there's actually a few more than what you see here, and they're adding some all the time, so do check with cisco.com to see what the latest compatibility matrix is. So it supports a variety of 1 gig and 10 gig, and I think it even supports some 40 gig FEXs now, as well as the B22. These are for the Blade systems, so the Blade system for Dell, Blade system for HP, Blade system for IBM, so it supports those FEXs as well. Now the idea of a FEX, there's trade-offs to effects. They're less expensive, and you don't do configuration on them, at least in NXOS mode. In ACI mode, it doesn't really matter. The ports typically are cheaper because they were used to aggregate the more expensive 10 gig ports off of like a Nexus 5000 or 5500 or 5600 or Nexus 7000 or 7700 to make the ports a little bit cheaper so we can aggregate them out, especially if you think about it. If you take an ESXi host, for example, which is what's very commonly plugged into Nexus gear, it's got a 10 gig interface. It's probably, it depends on your organization, depends on your workload, but that 10 gig port is probably not running at full line rate. It's probably running maybe even less than a gig. So it doesn't make sense to use up one of those Nexus 7000 or 5000 10 gig ports just for a single host. But with the 9000 series, the price per port has dropped substantially compared to a 7K or 5K. So it may not make as much financial sense to run FEX, but they are supported. Okay, so let's talk about the Nexus 9000 ASICs. These are the switch-on chips that are the engine underneath the hood of the Nexus 9000 series. Now, when Cisco first came out with the Nexus 9000 series in ACI, they pursued what they call the Merchant Plus strategy. So that means using common off-the-shelf components, such as Broadcom's Trident 2 switch-on chip, as well as their own specialized ASICs to handle some of the higher functions. or the more advanced functions that the Trident 2s didn't provide. So the industry baseline, the Broadcom Trident 2, it's a venerable chip. It's very common. It's widely used in a lot of different places and by a lot of different vendors. And it provides basic things like VXLAN bridging. It's got some buffers in it, 12 megabytes of buffers, provides visibility per port, as well as counters on packets and bytes. Now, there's some deficiencies in it for Cisco ACI to do what it wanted to do. It had to provide some additional functionality that were deficient in the Broadcom Trident 2 chips. Number one probably is VXLAN routing. So the Broadcom Trident 2, as well as the Broadcom Tomahawk chip, cannot do what's sometimes referred to as route in and out of a tunnel. So on an inbound packet, if it's destined for a VTEP on the chip, when it gets decapsulated, it can only forward that packet based on its layer 2 header. So it can't do a routing. It can't make a routing forwarding decision based on that. And the reverse is true for the most part. So the Cisco provides their own ASICs. First, they came up with the ASC and the ALE, which we'll talk about in a little bit, as well as some other ASICs to provide that VXLAN routing capability. Also added in some more buffer and some smarter ways to handle packet drops and buffer management. Also additional application visibility, things like atomic counters, end-to-end latency measurements, as well as dynamic load balancing, flow prioritization, multipath, inline hardware overlay database, basically storing the entire session or this entire state table in hardware, so nothing has to get looked up in software for the entire fabric, and then as well as fast reroute. So Cisco ACI ASICs. On the left here we have the ASICs that are provided by Cisco, and on the right we have the two Broadcom chips. So the first generation, on the top we have the 10 gigabit lanes. So these switch on chips are basically comprised of what's called SerDes, serializer deserializer interfaces. These become the basis for 10 gig interfaces and 25 gig interfaces. But what about a 40 gig interface, you say? Well, for example, the Trident 2, Cisco refers to it as the NFE, Network Forwarding Engine. The Trident 2 is comprised of 128 10 gig SerDes. So there's 128 of those coming out of the switch on chip. And what they do is they take 4 of them and they bond them together to create a native 40 gig interface. Now, that is not a port channel or ether channel or link aggregation group. So this is a sub-packet balanced, sub-packet load balanced flow. So it counts as a native 40 gig interface. If you think about it, if you take a look at the QSFP Plus interface, the physical optic, it's got 4 10 gig lanes on it. So it's got 4 lanes, 4 pairs of fiber on it. And it's providing 40 gig, so 4 by 10 gig lanes. So the NFE Trident 2 is the one used by a lot of the first generation Cisco ACI chips, and it's also used by a lot of chips, a lot of switches from other vendors as well. The older style 100 gig interfaces were referred to as CF2, and they were 10 of those SerDes bonded together to create a native 100 gig interface. The next generation is 25 gig lanes. So a lot of the new chips that are coming out are based on 25 gig. Broadcom has their own. Cisco refers to it as the NFE2 in the Nexus gear. And its code name is the Tomahawk. So this is, it is the same basically as the Trident 2, just everything's kind of ramped up a bit. It's 128 25 gig SerDes. And then if you take 4 of those together, then you can create a 100 gig interface. So we're seeing 100 gig supplant 40 gig in a lot of places because you can use the same cabling that you use to run 40 gig and just run, you're just increasing the lanes from 10 gig to 25 gig. So you can take the same fiber plant that you use to run 40 gig, the QSFP cables, and you can run 100 gig over those instead. Now, in terms of Cisco ACI, Cisco does not use the Tomahawk. So the NFE2 is not used in Cisco ACI. It is used in some of the other Nexus 9000 line cards and fabric modules, but they are not compatible with ACI, at least currently. So the Trident 2 is still used is for the first generation of hardware for the 10 gig hardware. On the left here we have the Cisco chips, 28 nanometer based and 16 nanometer base. We have the ALE2, the application Leaf engine, as well as the ALE2 and ALE2 Plus. So the ALE was referred to as North Star, and the ASC, the application Spine engine, which goes into the first generation Spine, either line card, the 40 gig line card of the 9500s or the 9336. So the 9336 basically has just one of these chips in here. Again, these are switch-on chips, so they have a number of 10 gig SerDes bonded together to create 40 gig interfaces or whatever, or they're used just 10 gig interfaces by themselves. And so the ASC was called the Alpine. The ALE2 and the ALE2 Plus were called the Donner chips. So those are just the nicknames of these, or the code names of these. But in documentation, you'll see them referred to as the ALE, the ALE2, and ALE2 Plus, and the ASC. So these are the 10 gig based switch-on chips, or ASICs, from Cisco. The new generation, the 25 gig based, are the LSE and the ASC. LSE stands for Leaf Spine Engine, and ASC2 is the application Spine Engine number 2, second generation. And they're based on even a smaller 16 nanometer die size. I do not know what the code names for these were, but in Cisco documentation, you'll see them referred to as the LSE and the ASC2, and they are both based on 25 gig lanes. So another look at these, we have here just a chart of the die sizes. 40 nanometers, 28 nanometers, and then 60 nanometers. The smaller the die size, the less power is consumed and less heat is thrown off. So the smaller the better. As well as the amount of buffer that's provided by each chip, the number of SerDes, serializer, deserializer interfaces, and what they run at. So for example, the Cisco ALE is 96 ports of 10 gig SerDes, and then you can combine them. So just take 96 divided by 4 and you get the number of 40 gig ports. And then the NFE2, the Tomahawk, provides 128 25 gig interfaces. Now, you'll notice here I have put in parentheses 96. That is because both the Tomahawk and the Trident 2 are oversubscribed. So if you want to run full line rate on all packet sizes, you have to turn off about 1/4 of the ports in order to make that happen. And then it shows which chips are capable of VXLAN routing. Now, if you take a look at a traditional data center switch, and even the Nexus 3000, some of them are like this, is they just have that Broadcom Trident 2 chip in there. And so they can provide a number of 40 gig interfaces, and then also a number of 10 and 100 gig, a number of 10 gig interfaces as well. So it could be something like, it could be 32 or 26 or something. Some number of 40 gig interfaces are supported. 32 40 gig interfaces would be supported total. And then every 40 gig interface could be instead be a bunch of 10 gig interfaces. And so that's a traditional chip, a traditional data center switch. And the Cisco Nexus 3000s, some of them are made that way. But of course, we talked about they can't route VXLAN, and one of the things ACI is based on is VXLAN, and we're routing back and forth, so we need to be able to provide that routing functionality. So that's why the ALE, the application Leaf engine, is there. So this is the Nexus 9396 PX and TX. PX means it's fiber, and TX means it's 10 gig base T interfaces. So the ALE, the Cisco chip, actually runs inside of that GEM module. So it sits inside of there, provides those there's 12 40 gig ports. These have to be, in ACI mode at least, they have to be plugged into the spine. They cannot be plugged, they're not host-facing ports or device-facing ports. So these only go into the spine. They can't be broken down into 10 gig links. You can't break them out. So these go up to the spine. And then these ports here, the 10 gig interfaces, go all the way go down to things like ESXi hosts, perhaps, or bare metal servers, or routers, or load balancers, or firewalls, etc. In the 93.128 version, we actually starve out a little bit on the NFE2, so only 8 ports are active, so we can only use 8 of those ports to go up to our spines. You don't have to use all 8, but you're limited to 8 on the 93.128. Now, if we take a look at the Nexus 9500s, we have the fabric modules. The first generation of fabric modules, based on the 10 gig lanes and provides 40 gigs of connectivity, are entirely based on the NFE, which is, again, the Broadcom Trident 2. So each one of these, we need 6 fabric modules to provide connectivity for each line card, to provide the full bandwidth, which is 1.92 terabits per second bandwidth. And basically, every fabric module provides 8 40 gig links to every line card payload slot. So, and then we have 4 payload slots. For example, this is then what we see in the 9504. Now, the 9508 has 2 NFEs, and the 9516 has 4 NFEs. But just for brevity's sake, I'm just going to show you the NFE, the 9504, because it involves fewer chips. And what we have is the ASE has 36 ports of 40 gig capability, and we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. 18 facing the fabric modules, and we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. 18 facing the front ports. So 18, each ASE is responsible for half of the line card ports. So we have 18 40 gig ports, and we have 18 40 gig ports, which gives us a grand total of 36 40 gig ports to provide connectivity to our leaves. And then, so each line card, each first generation line card, which is the 9736, X9736 line card, and it can only run in ACI mode. So that's how that bandwidth is provided. The second gen we talked about in the earlier section of this module is 25 gig lane based and provides 100 gig interfaces. We only need, so these fabric modules are not based on the Trident 2, and they're not even based on the Tomahawk, which is Broadcom's 25 gig switch on chip. It's based on Cisco's ASIC 2. So this is a Cisco ASIC. In fact, the Gen 2 spines have no Broadcom in them whatsoever. So each fabric module, we only need 4. Again, we're showing what happens inside of the 9504. So each fabric module, we only need 4 fabric modules, and each fabric module provides 8 100 gig links to each line card payload slot. Each LSE provides, 8, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. So we have 8 100 gig links facing back towards the fabric modules, and we have 8 facing the front. 8 times 4 is 32, so we get 32 100 gig links, and this is enough to provide non-blocking access for all 32 ports, so they can all run at line rate at all packet sizes. So this is in the non-blocking cloth fabric here. And then every line card has 4 of these LSEs. The fabric modules will have 1, 2, or 4 ASE2s, depending on whether it's the 9504, which has 1, the 9508, which has 2, and the 9516, which has 4.